Hello everyone, welcome to my channel. This is a channel for educational purposes. We survey and take deep dives on some of the theories of everything that you might have overlooked or never heard of before. Things that you can hang your hat on, things that you can stick your teeth into, things that will, if you study them, they will reward you by giving you a coherent, all-encompassing theory that you can, base your decision-making on. You can base your your internal paradigm on. And today is the 289th video that we have done on Dewey B. Larson's reciprocal system of theory. And Mr. Larson lived in the 20th century. He was an engineer. He was trying to figure out an equation for the interatomic distance between different elements, and stumbled across a hypothesis of what he should really plug into his equations, and that eventually led to him formulating his reciprocal system in his two fundamental postulates that came out in the late 1950s. And then from there, he used a process of induction and went from his fundamental postulates to the generalized theory of the universe, of how a model of the universe. And then he wrote books on things like chemistry and astronomy and metaphysics and physics and psychology and religion and economics, all based on the same theory, same set of postulates. And the first and major postulate that Mr. Larson put out basically states that we live in a universe made entirely out of motion. Not matter, not energy, but motion. Matter and energy are just two different varieties of motion, in fact. And along with really all of the other scientific quantities that we know of, including force and electric charge, electric current, magnetic flux, susceptibility, permeability, permittivity, capacitance, resistance, acceleration. These are all forms of motion. And what kind of distinguished Larson's universe of motion was that he defined motion as the relationship between space and time. That sets up a generalized reciprocal relationship between space and time. Space and time are basically the two elements that go into motion. They do not have any real independent existence, only together as motion and as two reciprocal aspects of motion. So motion is basically a fraction or a ratio with time or space as the numerator and space or time as the denominator, with the caveats that space and time are both, they both have coordinate aspects, meaning that they both can come in 3 dimensions, and that space and time both have their scalar or progressing aspects, meaning that a scalar motion is a motion that has a magnitude, but it has no direction, such as a clock, a clock is always getting later and later and later, but in no particular direction. And you can, there's Larson called that clock time. Clock space, you can visualize using a balloon with dots on it. You blow up the balloon, all the dots are moving away from each other, but in no particular direction. This is the progression of space, or the flow of space. All of the dots are moving away from each other. That is clock space. Space is always getting farther and farther and farther apart. And then the third general caveat is that space and time only come in discrete units. They are quantized. There is a minimum unit of space and a minimum unit of time below which you do not have space or time. So if you don't have a full unit of space, then you don't have space. And a corollary of that is that if you don't have a full unit of space, then you don't have space. And if you don't have space, then you only have time. Larson calls this the time region. And similarly, if you don't have a full unit of time, then you don't have time. And if you don't have time, that means that you only have space. And Larson refers to that as the space region. And also, if you have a full unit of space in a full unit of time, space divided by time, you have the speed of light, which Larson refers to as unit speed. 1 over 1 equals 1. The speed of light is the unit speed of the universe, which basically means that it's the midpoint, or the null point, or the origin, or the central point, or the 0 point, or the ether of this universe. And that there is half of the universe that is moving slower than the speed of light, which Larson refers to as the material sector, which contains the time region, and half of the universe that is actually moving faster than the speed of light, which Larson refers to as the cosmic sector, which includes the space region. So we basically have that third caveat sets up 3 separate boundaries in the reciprocal system: unit time, unit space, and unit speed. Unit speed divides the universe in half, and then unit time is a subset of the cosmic sector, and unit space is a subset of the material sector, or the unit space boundary, which is what he calls the time region. And so in the time region is the region inside a unit where the action occurs inside a unit of space. This is for microscopic, the unit of space is microscopic, 4.56 times 10 to the minus 8 meters. Very large compared to an atom, but too small for us to see. And that is the realm of the atomic and molecular world. That is all occurring in the time region. And in the space region, we have really the instantaneous. The unit of time is 1.52 times 10 to the minus 16 seconds. So anything less than that, and you're dealing in the space region. Okay, so we start with that. So we've got these 3 different boundaries set up here, and when you cross the boundaries, you basically, the rules change. You invert the general rules. So in the material sector, you have coordinate space, 3 dimensions of space, and clock time. Progressing time. Time is always getting later and later and later. But if you cross the boundary, the unit speed boundary, and you move into the cosmic sector, you cross the speed of light, and you start moving faster than the speed of light, then the roles of space and time invert. And you all of a sudden have coordinate time 3 dimensions of time, and clock space. Space is now always getting farther and farther apart. It's progressing. And so that shows how when you cross a boundary in the reciprocal system, a unit boundary, the rules invert. So Larson started with that, along with the second postulate, which basically indicates the math and geometry of the universe and has been subject to some dispute. But he then derived his entire theoretical universe from that, and wrote many books and articles on the subject. But then Mr. Larson died in 1990 and left behind a handful of followers, some of whom were well-versed in the reciprocal system, especially Dr. KVK Nehru, a professor from India, who started following up on the reciprocal system, I think, way back in the 1970s, and has written many, many articles on various aspects of the reciprocal system. We are looking at a paper that Dr. Nehru wrote that is called Glimpses of a New Paradigm. And this is kind of a summary of, some of the more easily explainable features of the reciprocal system. We've done 2 episodes on that so far. So this is the 3rd episode. So if you want to go back to the beginning of the paper, go back a couple episodes and listen to those videos. We are going to repeat one paragraph, but then go on. This section of Dr. Nehru's paper is called The Grand Cycle of the Universe. We've already mentioned that quasars are the high, greater than unit speed explosion products of aged galaxies. When gravitation in space is attenuated by distance and becomes negligible, the quasar as a whole shifts from the region of less than unit speed, the conventional spatial reference frame, to the region of greater than unit speed, the 3-dimensional temporal reference frame. So that's just what I was just talking about. The quasar is something that does cross that speed of light boundary. And when it does, the rules shift. It shifts from being 3-dimensional space to being in 3-dimensional time. And then in addition, it also shifts from being in clock time to being in clock space. Gravitation ceases to act in space and starts acting in time. This leaves the outward progression of space-time without check, as there is no inward progression of gravitation in space. And the constituents of the quasar start flying out in space at unit speed. That is the progression of space. So once it goes into this cosmic sector, instead of getting later and later and later in time, now it is all of a sudden getting farther and farther and farther apart in space. Eventually, the quasar ceases to exist as a spatial aggregate and disappears altogether from the material sector. In other words, the atoms of the erstwhile quasar emerge into the 3-dimensional temporal reference frame of the cosmic sector at totally random locations. So, basically it crosses over into the cosmic sector, and then it basically, disintegrates, because it starts getting the different aspects of the quasar start getting further and further and farther apart. The corollary is that similar set of events occurs in the cosmic sector. Cosmic atoms aggregate in three-dimensional time, forming cosmic stars and galaxies, parts of which explode on attaining a size limit and eject cosmic quasars, which eventually exit the cosmic sector and end up entering the material sector. Since they come from a region not localized in space, these incoming cosmic atoms would be uniformly and isotropically distributed throughout the three-dimensional space. Again, isotropic basically means it looks the same in all directions. Okay, so these incoming cosmic atoms would be uniformly and isotropically distributed throughout the three-dimensional space. Since the transfer occurs at the unit speed, we ought to observe these particles at unit or near unit speed. These, of course, are the observed cosmic ray primaries. So the cosmic rays that the scientists have observed are the result of cosmic quasars. The reciprocal system traces out in detail how these cosmic atoms, being greater than unit speed structures in a less than unit speed environment, promptly decay, ejecting speed and cosmic mass, that is inverse mass, or inverse speed also, or energy, and cosmic mass, finally ending up as the most primitive structures of the material sector, namely hydrogen. Now, I think Larson says that they actually end up being massless neutrons, and then they would probably have to build up to hydrogen from there. Anyway, there may be some dispute between them about that. Then the entire cycle of aggregation in space and eventual ejection begins. In the long run, as much matter comes from the cosmic sector as it leaves the material sector. Thus, the dual sector universe as a whole is in equilibrium and steady state, while each sector continues to expand in space or in time, as the case may be. There is no necessity to assume the singularity of a Big Bang or to break any conservation laws as in continual creation. Okay, so Larson's universe, once it gets started, is just a steady state. Things flow from the material to the cosmic sector, and an equal balance is created by things that flow from the cosmic to the material sector. So when it flows out of the material sector to the cosmic sector, it becomes new matter in the cosmic sector. And then when it flows back to the material sector, it becomes new matter in the material sector. So the origin, of matter in the material sector is the cosmic sector, and vice versa. Now, I'm not sure when I use the term new, new is really referring to time. And so maybe in the cosmic sector, you would say close together matter instead of new. But anyway, the next section here is called the solid state. Because of the fact that the minimum space that can occur in physical action is one natural unit of space, the quantum of space, if two atoms are made to approach each other, they cannot come any nearer than 1 unit of space. However, by virtue of the reciprocal relation between space and time, these atoms can accomplish the equivalent of moving inward in space by actually moving outward in time. Okay, so now he's talking about a different boundary. Okay, so when we're talking about the quasars, we're talking about crossing over from the unit, crossing over the unit speed boundary, the speed of light. The quasar breaks through the speed of light and moves into the cosmic sector, or the cosmic quasar breaks through the inverse speed of light and into the material sector. That's one boundary of the universe where the rules change when you break through. Now we're talking about the two internal boundaries of each sector, or one of each sector, the time region and the space region. The time region is the region of less than a unit of space, and the space region is the area of less than unit time. And so when you break through those boundaries, you also have to invert the rules. Okay, so because of the fact that the minimum space or unit space that can occur in physical action is one natural unit of space, if two atoms are made to approach each other, they cannot come any nearer than one unit of space. However, by virtue of the reciprocal relation between space and time, these atoms can accomplish the equivalent of moving inward in space by actually moving outward in time. So they can't move any closer in space because there is no space. What, less than one unit and you don't have space, then you're actually in the time region. And so the only thing that you can do is move outward in time, which by the reciprocal relation is equivalent to moving inward in space and is seen by us as an inward motion in space. We do not see, from our perspective in the material sector, we do not see time. We only see space. We see time only as it affects space. So like an example of that is like iron filings in a magnetic field. The magnetic field is in time. We do not see the magnetic field. We only see the material iron filings, the pattern that it forms in space. So we don't directly see the magnetic field. We only see the effect that it has on space. Okay, so the same thing is happening here within the time region. Once they get to a minimum unit of space, then they can no longer move in space because less than one unit of space does not exist. At that point, you only have time. So the only thing that can happen is you move outward in time, which is the equivalent of inward in space. And so he says this they promptly do until a force or motion, a force equilibrium is achieved, giving rise to the solid state of matter. So the solid state of matter is an equilibrium that is arrived at inside the time region, where, you know, the forces are all equal. Since less than one unit of space does not exist, within the unit of space, all motion could be in time only. Larson therefore refers to the inside of unit space as the time region. The space-time progression always acts away from unity. In the outside region, away from unity is also away from zero. But in the inside region, away from unity is always toward zero. Therefore, the space-time progression is inward in the time region. So when you're within the time, so basically you have the space-time progression, and then its opposite is gravitation. Normally, the space-time progression is moving everything farther and farther and farther apart. And gravity is moving everything closer together. Again, you can use your balloon with a dot with dots on it. You blow up the balloon, that's like the space-time progression. You suck in the balloon, that's like gravitation. But once you get into the time region, the region inside a unit of space, the rules reverse, and now gravitation is actually moving things farther and farther apart, while the progression is moving things closer and closer together. Outward in time. When you are moving something outward in time, it is seen by us, and its equivalent is inward in space. So, in the outside region, away from unity is also away from zero. But in the inside region, away from unity is toward zero. That is the progression. Therefore, the space-time progression is inward in the time region. It's inward in space in the time region. It's equivalent, but it is outward in time. So I would kind of revise that sentence. But since gravitation always opposes space-time progression, it acts outward in the time region. Again, I would say that that's equivalent outward in the time region. It appears to act outward in the time region, from our viewpoint. Okay. Further, while the space-time progression is constant at unit value, gravitation attenuates with distance, meaning that, the further apart you are, the less the force of gravity. The two motions, or the two forces, that of the progression and of the space-time and of gravitation, therefore reach a stable equilibrium at some distance in the time region and produce the configuration of the solid state. So this is the equilibrium that he was talking about between those two forces that creates the solid state. Larson finds that a single theory of cohesion, atomic cohesion, explains all kinds of bonds. The different bonding between atoms and molecules. Basing on purely theoretical computations, he is able to calculate quantitatively the various solid state properties of hundreds of elements and compounds accurately. Okay, we will see that when we look at his book that is called Basic Properties of Matter. And he has a chapter in there called Interatomic Distances. He has another chapter called Distances and Compounds. This is where he takes his he takes his fundamental postulates and applies them through a process of deduction and comes up with a theoretical universe. From his theoretical universe, he calculates different basic properties of matter, such as the melting point, the boiling point, the interatomic distance, the compressibility, all of these different qualities, properties of matter. He calculates them strictly from theory, and then he compares his calculation to the actual scientific tables that have been published about, what is the boiling point of oxygen? What is the boiling point, or, what is the boiling point of, silicon, carbon, all of them. And he predicts them, and, 90+% of his predictions are within like 1% of the experimental value, or whatever. Occasionally there are a few glitches, but usually he's able to explain those for one reason or another. It's actually, when you talk about, bringing the receipts, I mean, he's either fudging the numbers in such a complex way that we don't get it, or I don't get it at least, or he's bringing the receipts, because he's able to basically reproduce the scientific tables that have taken, you know, generation after generation to compile about the basic properties of matter, and he's able to do that basically off the top of his head. So, you know, strictly from theory. We will get into that when we do look at his book, Basic Properties of Matter. Okay, now the next section here is called New Light on Quantum Phenomena. And Nehru goes into quantum mechanics quite a bit here, not in this section, but in a different article that maybe we will take a look at down the line. But we will start with this section when we resume tomorrow. Now, for me, just reading this was very revelatory. He kind of just clicked me in on a couple things, and I'm definitely going to go back and read this article again. There's a lot to this article. You know, a lot of times people, you need the repetition. People, you know, I could read Larson over and over and over and over again, or I could read Nehru over and over and over again, and it might not just hit the right way on my wavelength, what I'm thinking about. But then one time I'll read it and it's like, oh, that's what he's saying. And I had a couple of those moments here just now reading this. And so I'm excited for myself, and I hope that some of you as well were able to click with some of this. And if you didn't, just repeat, you know, sleep on it for a day and repeat, and it might click for you that time. It doesn't always happen like magic, but when it does, it's very exciting, because you broke through a conceptual hurdle. A lot of times our conceptual hurdles are related to the wrong think that we had plugged into us from our schooling and so on, and our faulty paradigms. And so we got to clear those away. And so sometimes, you know, you have to be patient in, you know, you can't just drop your old paradigm until you have something to replace it. So, okay, well, hope you all have a great day, and I hope you tune in tomorrow.